Okay, you've survived the first 3 chapters of statistics. So chapter 4 is all about probability. Probability, this first section is only talking about probability, nothing fancy, just some overview. So I'll try kind of make it kind of quick. Okay. Probability is the numerical measure that indicates the likelihood of the event. It can be anywhere from impossible, which is 0%, or certain to occur, which would be 1 or 100%. Every probability has to be within that range, and obviously the closer you are to 1, the more likely it is to occur. Capital letters are what we use to kind of to name an event. So the probability of A, that's how I read this right here. Probability of A means that's the probability of something occurring. Once again, like I said, it's in between 0 and 1. Obviously, the probability of A equal to 0 is not going to occur, and the probability of 1, it definitely is going to occur. The method to find probabilities, there's 3 ways. Intuition, basically thinking it, relative frequency, doing it, and then equally likely outcomes, and I will show you that in mere minute. Assignment by intuition is basically experience or judgment based on our confidence that something's going to happen. An example of this, based on the previous year's sales and the manager's projections, the price or the chance of selling 100 plasma televisions on the Friday after Thanksgiving is 75%. So basically this might be from previous examples or anything like that. That's intuition, using past ideas. Relative frequency. This has come up in histograms. It's the fraction of time an event occurred in the past. So relative frequency, we have calculated this many times. The frequency to the number of times we've tried it. So this isn't necessarily theoretical, this is experimenting, actually doing it. So if you flip a coin 200 times and head comes up 104 times, your probability of getting a heads is not 50% like we theoretically think. It will be the 104 divided by the 200, which is 52%. If you note, here's another way. If you note that 57 of the last 100 applicants for a job have been female, the probability that the next applicant is a female would still be the 57 out of 100, because that's just been past experience, past information has been gathered, and that's what we're getting. So probability of the female is 57%. The law of large numbers. This is going to come up a little bit more often as we progress through this semester. In the long run, as sample sizes increase, so the larger or the more times you try something, the relative frequency will get closer and closer and closer and closer to the theoretical probability. So you might flip a coin like 4 times and get 4 heads in a row. That's quite rare. If you flip a coin 10 times or 100 times, and the higher and higher you get, so if you go 200 times, 500 times, 1,000 times, you're going to get closer and closer and closer and closer to the theoretical probability of 50% to get a heads. And you can run these tests on computers and different things like that. It's pretty interesting to kind of look at that and how the law of averages does indeed work. Equally likely outcomes. Here's where you actually think about it. This is our theoretical way. No one event is expected to occur more frequently than the other. Okay, so here's an example. If you roll a die, a 6-sided dice. So there are 6 equally likely outcomes. 1, 2, 3, 4, 5, or 6. So what's the probability of rolling a 3? All of you are like, well, 1 out of 6. Perfect. Roll an even number. 2, 4, and 6 are the options, so 3 out of 6. You can reduce that to 1/2. Rolling a 4 or a 5. 2 out of 6. Pretty elementary. Nothing too difficult about it. So probability definitions that you may want to write down. So what is a statistical experiment? A random activity that results in a definite outcome. The event is the collection of the outcomes. Simple event is when one outcome it consists exactly of one or any subset of the sample space, and we'll talk about sample space right here. Sample space is just listing them all. Okay, so an event would be the collection. A simple event is one of them. A sample space includes all of them. So here's a statistical experiment we could do. We could flip a coin and roll a 6-sided die at the same time and see what happens. The sample space. Sample space is simply listing in brackets every possible combination. So notice that the H stands for heads. You could flip a heads and then roll a 1. Flip a heads, a 2, and so on down the line to tails 1 all the way through tails a 6. Simple events would be listing them separately. So you get a heads and you roll a 1. That's one simple event. Okay? Event examples. So what would be an event? Maybe I want to know what's the probability of flipping a head. What are my options? Okay, one of the events could be head 1, head 2, all the way through head and rolling a 6. Event example of rolling an even number, listing them out. Rolling a 5, listing them out. Flipping a tail, and a number less than 3. Okay, tail 1 and a tail 2. Those are your options. Now actually finding the probability is a little bit different. What is the probability of flipping a head? Well, what do we have? Our sample space shows that we have 12 total options if you add them all up. So how many options will allow us to get ahead? 6 of them. 6 out of 12 should reduce that to 1/2. And then you keep on going down the line. What's the probability of rolling an even? Also 6 out of 12 should reduce to 1/2. Probability of rolling a 5. There were only 2 options. You have to get a heads and a 5 or a tails and a 5. So 2 out of the 12 should reduce down to 1/6. That's a horrible 6. And then flipping a tail and rolling a number less than 3. Also only 2 options to make that true out of the 12. Probability rules. The sum of all the probabilities in an event must, in the sample space, must equal 1, because you have to include everything. So the probability has to equal 1. It's just the way it's going to be. And what's important to know about that is you can always use the complement rule. What is the complement? Complement is simply just the event. If something happened in A, it's what doesn't occur. It's what's left over. Okay? So if A stands for the event that it rains tomorrow, the complement then would be it's not going to rain tomorrow. So now I've seen it denoted 2 ways. This could be the way of denoting the complement. I've also seen it denoted as A prime, A with the little asterisk on top. So that is another way that can be denoted. So the probability or complement could be A prime as well. So the probability that it rains could be 44%. The probability of not raining, or the complement of it, you just simply, that's why this is important, you can just take 1 minus the 44% and make it 56%. And the reason that is all the probabilities must add up to 100% or 1. So that's the important part with the complement rule, is understanding that. Here's a picture of this. This is the same idea. If this is all of your data in this circle, the rest of it is the complement. And the box is kind of a picture for your whole. Okay, 2 last things. Probability versus statistics. Probability is the field of study that makes statements about what will occur when a sample is drawn from a known population. So an example of this is a random draw of 20 people. How many females would we expect to draw if we knew that the population of 100 people has 60 females? So we know everything about the population. There's 100 people and it has 60 females. So you could say, hey, 60% of the females, or of the sample is females. So if we draw 20 people, we should expect that 60% of them, or 12, are females. That's the idea of probability, is we have a known population, we know exactly what's happening, and we're randomly going to draw. Whereas statistics, where we're going in this class, is the field of study that describes how samples are to be obtained and how inferences, we're going to make inferences about unknown populations. So maybe we're going to randomly draw 20 people, and we figure out that we got 13 females out of those 20. And we're going to say, hey, what's our best guess for the percentage of females in a population of maybe there's 100 people? Would we expect there to be 65% females? That's the question. And that's what statistics is we got to make inferences, and we're going to guesstimate the best that we possibly can given the parameters that we have about it. So that's the difference between probability and statistics. Probability, we take a known information and make well, not inferences, but we get answers, whereas statistics, we're going to make inferences about the population. So tomorrow we're going to do this assignment. What I'd like you to do for note credit, I would like you to take a piece of paper, write your name on it, And I'd like you to just write "math is fun" and hand it to me as you walk in the door tomorrow for a grade. I want to see who is actually listening all the way to the end. Hope you have a great day.